Hey, well, welcome back. This is edition number 3 of the Pulling Your Homework Physics Series podcast. And today we are going to get started with my book here, The Elegant Universe. Well, not my book, but that is my copy. And I am finally starting to read it. I got through the first section, part number 1, entitled Tied Up with String. And he does a pretty good job. He starts digging in. He starts telling the story of atoms and kind of how all that stuff came to be. If you don't know it, it's very interesting. But I guess my reaction to it is what it made me think about is when I was a little child, and the first time someone had even suggested the notion that, like, I'm made up of small little parts, like even cells. Like, I guess just, as a kid, you sort of think you're this nice continuous unit, and it doesn't occur to you that there may be anything else there. But so I guess as humans, maybe we find out we're made of cells, look at a microscope, and then molecules and all the organelles inside the cell make up the little parts of the cell, and then they're made up of molecules. But even before that, 2,000, 3,000 years ago, the Greeks posited that we are made up of atoms, small little indivisible parts. They didn't exactly know what that meant, but then as, chemistry wore on, we found things like carbon and oxygen, and we figured, those must be the atoms that they were talking about, so that's what we called them. We started referring to them as atoms. And then as we dug a little deeper, we found out that those atoms are actually made up of building blocks. Protons, neutrons, and electrons, and that's it. Everything's made out of protons, neutrons, and electrons. And for me, for whatever reason, that level makes sense. Like, atoms are made up of protons in the middle and neutrons in the middle. You got electrons orbiting, and for whatever reason, I'm fine with that. I guess maybe the moon goes around the Earth, and so that notion doesn't seem that crazy. And everything is made up of that. But when you start to think about it, even that notion is a little crazy. Like just these little orbiting planets, I guess you would say. And that's what makes up everything. That's everything. But we know that now, not even that is it. There are what are referred to as quarks, up quark and down quark, make up a proton, and electron is an electron, nothing else beyond that. And then there is this other little guy named the neutrino. And so that's the one family. But then, as he says, there are 3 families. So you have the electron, and the muon is then or the mu electron, as he says, is the same thing as an electron, but for whatever reason is like 200 times heavier. All right, and then you have what's known as the mu neutrino. Same idea, it's like the counterpart to the neutrino. And then you have 2 quarks, which are the same analogs. We have this family, and then we have the same thing again, even more heavy, and it's the tau family. And the question that he asks, which I think everybody asks, is why? Why are there like a 3x4 style family? There's 4 families, and then we have 3 real elements. The neutrino is like this thing that's just hanging out somewhere else. Nothing that we know of is made up of neutrinos. Everything's made up of up quark, down quark, electron, right? So it's kind of like a 3x3, kind of like a 4x3 matrix of stuff. And now, let's not even get into the fact that there's even more than that. And then he kind of gets into this notion that there's like, so why are those things existing? But let's just set that aside for a second. Then we have the forces of nature. You got electromagnetic force, gravity, strong force, weak force. So strong force is what holds protons and neutrons and electrons all together in the atom. What attracts them, even though electromagnetically they should repel. And we don't, at least at this point of the reading, we don't know what the hell's going on there. But okay, it's just let's just take that. Then you have the electromagnetic force, which describes like every interaction on our scale. And then you have gravity. And gravity, nobody knows what's going on there. Mass attracts mass, and that's it. But we do know that there are these particles called gluons, apparently, that are responsible for the strong force. And they posit that there's something called the graviton, which would be responsible for gravity, which would really simplify everything. And gravitons make sense, but they're not there. So another big question mark. And the question is, again, why? Why are there four... So weak force kind of has been combined with the electromagnetic force to form the electroweak force. And so they're kind of, shades of the same thing. And Einstein, and he touches on this again in the introduction, posits, the nice idea would be that there's one grand unified theory, or theory of everything, which he abbreviates TOE. And wouldn't it be nice if everything was just kind of shades of this one underlying thing? And not that we would, science is over, or, we understand everything, but it's based on one underlying theory, and then everything is built on one massive foundation, instead of having, these zillions of particles, and this random amount of forces, and, the other question is, why, gravity is very weak. Gravity is a very weak force. You need a lot of mass to do anything with gravity. But then with electromagnetism, you don't really need that much. You got these little electrons that put out an insane amount of, electromagnetic force. But then you also have the strong force, which is wildly even stronger. So the order of magnitude between the forces fluctuates. Now, what he promises is that string theory will explain all this and make it all fit nicely with a bow on top. And if you're a good scientist, anything with a bow on top is big question mark, big red flag, because if we've learned anything, it's that nature does not present itself in a very nice fashion. So that's, what he's described so far, and it would be out. So I love string theory. I am captivated by string theory, and so after I read this book and get my, surface level understanding of it, I would like to dig deeper and get a real text, with a little bit of mathematics flying around. But this is what I got so far, and so far, I'm familiar with all this stuff. And so the idea is that quarks and everything else are made up of strings, and that strings are just one little loop that vibrates in a certain way, and then everything is a manifestation of this string. And if the string vibrates a certain way, you get electron. If the string vibrates another way, you get a up quark, so forth and so on. And so everything else is just a manifestation of these little strings vibrating in different ways. Kind of like, if you play different notes on a guitar or a violin, you get different sounds. And so this is, how they're trying to explain it. And it kind of makes sense, if everything is just wavelength and frequency, and everything is just energy. We know mass and energy are related. Mass sped up fast enough becomes pure energy, and energy slowed down enough becomes mass. So, has a ring of promise to it. But the other thing that he said that I thought was very interesting was that string theory is like a 21st century theory that accidentally got discovered in the 20th century, which really kind of sounds right, because don't have the tools yet, or at least at the time of this writing, which was 2000-ish, a little earlier than that. It's an alien left us a supercomputer without the manual, and we were trying to figure out what the heck was going on. And it sounds about right. And so we know, this is 2015. String theory has not been widely accepted as the theory, but it does answer a lot of questions. And if it's right, then simulation theory, either the program is really good, or it is kind of the theory of everything. It blends quantum mechanics and classical mechanics in a very seamless way. And if it's all just strings, I'm fine with that. That sounds like a great idea. But we will find out. So the next part I will read this week, and I'll dig into the next chapter, and we will continue the debate next week. So with that, I will catch you later. This has been Physics Fridays, or as I like to call it, engineers in cars talking about physics. And if you get the reference, good for you. If not, maybe I'll tell you next week. So until then, I'll see you later, guys. Take care.